Good morning, Year 4, and welcome to your science lesson for Tuesday, the 12th of January. This is our second lesson of our new sound unit, and today we are going to be explaining how different sounds travel. Some of our steps to success today, we're going to be describing how vibrations make sound, so going on a little bit more than last week. Then we will explain how vibrations change when sound gets louder and how loud and quiet sounds travel to our ears. Okay, so first question today. Do you know how sound travels? What do you already know if you know something? Have a think about that question. Pause the video here if you want to have a think about that, or if you're in school with the key worker group, chat to the person sat next to you. And then have a think about where you would place yourself on the learning pit at the moment. Do you already know quite a lot about how sound travels, or are you not that sure at the moment? And that's fine if that's the case. Okay, we're going to start with our odd one out today. There are 4 pictures. Which one do you think is the odd one out? There's a picture of a guitar, a girl and a boy talking, a recorder, and a drum kit. Which do you think it is and why? Is there only one answer? Think about which ones it could be, because there's not just one right answer, but think about the reasons why you think it. Again, pause the video here if you need a little bit longer. Okay, today we're going to be talking about vibrations, and last lesson we learned about vibrations and how they can be seen and felt as well as heard. If we were in school, we'd have done this little mini investigation and we would have found out if the vibrations change when the loudness of the sound changes. So what I would have done is I'd have had a big drum that unfortunately I don't have at home, and I would have taken that drum and I'd have put some rice on the skin of it. And what I'd have done is I'd have hit it quite hard, hit it medium, and just gently tapped it. And we would have watched or observed the way the rice vibrated each time. What do you think might have happened? Obviously, I can't show you this at home, unfortunately, because I don't have a portable drum, but what do you think would have happened? Chat to the person sat next to you, just have a think about it if you're at home. Okay. This is then the science behind it, and this is what we would have seen had we been in school. So the louder the sound, the bigger the vibration. If I clap my hands really loudly together, there is a bigger vibration. And you would have, and it says should on there because we would have done it, but you would have noticed that the rice grains vibrated more. They'd have bounced up and down more if I'd have hit it loudly. It therefore created a louder sound, so it created more vibrations. And the size of the vibration is called the amplitude. You can see on this picture just below me, a big amplitude where there is big ups and downs. The range is bigger, shows there was a bigger amplitude. Quieter sounds have a smaller amplitude and the louder sounds have a bigger one. So the bottom one on this picture, all the way at the bottom, the range is smaller. So that would have been almost hitting it at a medium or maybe even a gentle if I was using my drum and my rice. So how does sound travel? We know if I hit a drum, it's going to make vibrations, it's going to be a loud bang. But how do the vibrations from the drum travel into everyone's ears? What do you think happens? And I really do want you to pause this video here, have a think, discuss with someone at home, if you're in class with one of the other classmates, what do you think happens with the sound and how it gets to your ears? Okay, well done for having those discussions. Let's find out. Oh, it's what Emmett thinks first of all. Emmett thinks, I think sound can travel through the air because the air is lighter and easy to get through. So Emmett thinks it can get through and it's easier to get through than solids or liquids. Do you agree or disagree with Emmett? And have a think about why. So again, you can pause it here if you need to, or just have a think about what Emmett said. Is it because it can go through air? Because air is quite light or very light. Okay, now let's find out. So we're going to watch this clip to see if you can identify how sound travels. It's better than me explaining it for you. Okay, hopefully you can see this.
Why can't we hear this alien scream in space? And have you ever wondered when you make a sound like How does the sound actually get into your ears? Watch what happens when the spaceship crashes on Earth. That's more like it. So why is it that we can hear the aliens scream now? Well, sounds are made from vibrations. We can't see vibrations, but if we did, they would look a little like this. Sounds are made when objects vibrate. Sound waves make the air around vibrate, and the vibrations enter your ear. You hear them as sounds. In space, there is nothing for the sound waves to travel on. That's why we can hear the aliens scream.
Okay, quite a fun little video there to show you that it doesn't go through the air, but it vibrates. So it says here that sound can travel through solids, liquids, and gases. And sound travels as waves, vibrating the particles in the medium or the thing it's traveling in. So the particles within the air, within liquids, within gases, they vibrate because of the big vibration that has happened. So in our example, when you hit the drum skin vibrated. This made the air particles closest to the drum start to vibrate as well. And then the vibrations passed on to the next air particle, then the next, and then the next. And this carried on until the air particles closest to your ear vibrated, and that passed the vibrations into your ear. That would be exactly the same, even if we don't have the drum. If I clapped my hands here and somebody else over the other side of the room would then hear it, because the air particles beside my hands, first of all, starts vibrating and it passes through those particles. Hearing sounds then. So once it's in your ear, the vibrations travel into the ear canal until they reach the eardrum. Lots of this vocab, by the way, might be new to you. You might be able to spot some on the diagram, but we will be going through this a bit more next lesson as well, so don't panic. The eardrum passes the vibrations through the middle ear bones, so the hammer, the anvil, and the stirrup, into the inner ear. The inner ear is shaped like a snail and is called the cochlea. Inside the cochlea, there are thousands of tiny hair cells, and hair cells change the vibrations into electrical signals that are sent to the brain through the hearing nerve. The brain tells you that you are hearing a sound and what that sound is. So you can see in this diagram below, just here, you can see the outside of the ear. And in my ear, you can't see what's going on within, but this picture here is quite clear in that it shows the way the ear goes in, and it shows these funny things, including that snail-like shape that I read about on the side. So we're going to be finding a little bit more about what actually happens in the ear next lesson, but it travels all the way through the ear and then it connects to your brain. Your task today is quite simple from this, but it's going to have to be slightly different because we're not in school and not with our friends. It says your task today is to make your own information or educational program. You should use the ideas that you've seen in the clip and come up with your own way of dramatizing and explaining how different sounds travel. So you're going to be presenting that information and recording yourselves in whatever fun way you can. So it says to use the Science of Sound sheet. So that's the sheet below here that you can see on the screen now. And I've also popped it just into a different format if you scroll down on the daily planning sheet for today. And you will plan your ideas. And then you'll practice what you want to do and what you want to say. However, you need to make sure that your explanations, your scientific explanations, are clear and easy for your audience to understand. Imagine that you are sharing this with the year threes who don't know much about how sound travels yet. Have fun and try and get into character. So you can see on this sheet below that there are 4 boxes. And it just says at the top, very similar to what I've read out, you've been asked to create an educational program for children to explain how different sounds travel to our ears. The producers, which are the people in charge of the program, want you to explain the link between the loudness of a sound and the size of the vibrations and explain how these sounds reach our ears. Work with your group. So if you're in school and a key worker, you could potentially have a group. If not, I'm afraid you're going to have to work at home, but don't worry because we've got pretty used to working alone. And you need to make sure that your explanations of how sound travels are clear and easy to understand. It says you may choose to use pictures or diagrams to support your explanations. and these 4 boxes will explain what you need to include. So if I scroll the page down, you can do your planning on here, and there are some words right at the bottom to help you. So the first thing you're going to need to do is to introduce yourself and tell the audience what the program is about. So you might say, hello, my name is whatever your name is. I am here to tell you all about sound today. I'm from BBC News Round. Then the next one, it says to explain the link between the loud and quiet sounds. Number 3, explain how sound travels. And number 4, give your audience any other information that you think they might need. This is really hard for me to model at home with you. So the only thing I thought about is showing you a very quick clip, and not the whole thing, from some of my year 4s last year. I hope you enjoy this and you'll probably recognize some of them.
Welcome back to school. Today we're going to be learning about sound. What sound and what are these things in front of me? I don't know a thing about sounds. How does sound work? I know. Lexi, here you go. Don't eat it, shake it. Oh yeah, I didn't know that. What sort of sound does it make? It makes a rattling sound. I have some things in front of me. They look like fruit. I'm going to eat them. Shake it. Maybe this one's real. Shake it. This one.
Okay, so I'm not going to show you all of their performance, all of their program from last year, but you can see how when the girls worked together last year, they had some rattles and things at home that they were shaking and that they were explaining just in a minute, that I'm not going to show you all of. They explained why they shook, what was inside them, where the vibrations were coming from, and how they then traveled to your ear. You can see they did it in quite a fun way. Again, there was more of them, so this will be slightly trickier for you at home alone, but you can use anything around you. Even if you don't have rattles and things at home, you could use a water bottle, for example, and hit it. You can see what happens to the water, and you can explain what is happening with the sound. Your planning sheet is the part that you can send to me if you want to, as part of your favourite piece, if it is your favourite piece today, or you can take some photos of you doing your performance, or even a video if you would like to. Hopefully quite a fun task today to try and make it fun, but just make sure you get the science right in there. Okay, off you go. Pause the video here and come back at the end just for the learning pit if you'd like to. Good luck and have fun. Okay, I'm sure they will be amazing and I can't wait to see them. Before you finish today, or we finish for our science today, think about what working scientifically skill we may have focused on today. What might we have been looking at? And again, you can pause and have a look at these. And finally, just think about where you were on your learning pit. What did you think of your educational programme? Were your explanations clear? And where do you think you are on the learning pit in terms of knowing how sound vibrates and how it travels? Excellent work again today. I will see you next week for science. Bye for now.